There we go. Now we're live. Okay. So, hello everyone and welcome. I'm Beege. This is Code Soul. I apologize that I'm not feeling so great, but this all happened kind of yesterday, and I'm like, I'm not going to cancel the day before the event, so I apologize that you have to deal with slightly nasally, maybe coughing now and then Beege, but yeah. But today we're going to cover...
sorry, bad news.
Whoa.
Sorry, guys.
Lost my train of thought. Today we're going to cover an intro to RabbitMQ and message brokers in general. Also, if you plan to follow along, I hope you have your laptop, but it is not required that you follow along. And if you do have your laptop, I hope you have Docker installed and Git installed and Python installed. Otherwise, you better hurry or just not follow along. So, let me get my notes back up here. Let's go ahead and get started. So, as usual, my disclaimer every time, I am not an expert on this. I am not a RabbitMQ guru. This is just the knowledge I have acquired through my work, plus other stuff I've studied specifically for this event. So do test stuff yourself. Be a good computer scientist. Check and test, all this sort of good stuff. That said, what we're going over today, we will go over a little bit of theory first, okay? But we're not going to go too deep, all right? We're not going to do like DSA crazy stuff. That is not what we do here. And then the second half will be actually working with a message queue. We'll have you set up a message queue on your machine. We'll have you create a producer and a consumer. If you don't know what those are, you will by the end of this. And then we'll talk about some kind of real world use cases where you would set up a message queue, how you might do that, this sort of stuff. So any questions about the agenda before we get started?
What's the DSA thing that you mentioned that we're not going to talk about?
So for the benefit of the stream, what is the DSA thing that I mentioned that we're not talking about? DSA is short for data structures and algorithms. It is very much computer science theory. It's a very popular thing for interview questions, even though everyone hates it and thinks it's stupid to ask during an interview, which I agree with, but that is a thing. However, if you are interested in DSA because you are worried about those interviews, we do have events on, I think, Tuesday nights online that does DSA practice. So if you want to study your algorithms and data structures, check that out. It's all online. Yeah. But yeah, any other questions before we get started? Cool. For our first-time attendees, when we're not in a rush, and I actually had proper time to prepare this one, so I shouldn't be in a rush today, I wait an uncomfortably long amount of time when I ask if people have questions. This is intentional, because I want to give you time to think of the question, gather up the courage to say it, think of how you're going to say it, and then get it out. So it's going to be uncomfortable. Deal with it. But let's dive in, all right? So first off, what is a message broker / message queue? So a message broker is basically a queue. Going back to a little bit of computer science fundamentals, a queue is like a line at a bank, right? The first one in is the first one out, right? The last one in is the last one out, right? It takes things in order and spits them out in order. That data could be of any format. It could be JSON data, it could be XML data, it could just be bytes, it could be binary, whatever. And it allows multiple services to pull data off of this queue and do all sorts of stuff, right? Sounds pretty simple. And at the highest level, the basic concept is pretty simple. But it's very powerful. There is a lot of cool stuff you can do with it, especially when you're talking about very large-scale distributed applications. And we're going to dive into that. So a message queue queues up messages, okay? And that's its main job. But it works with other components, usually other software that you write, okay? So there's usually a producer or publisher that sends messages to the queue, okay? You'll hear producer and publisher used interchangeably. If you hear these two words, they're the same thing in this context, okay? And then consumers receive or fetch messages from the queue. Okay? Consumers is pretty universal. All right? Do those two concepts make sense? Producers and consumers. So
are you going to talk about subscribers as well?
So, good point. And thank you. I should update the presentation with that. Another word for consumers could be subscribers. They subscribe to the queue to receive messages as they come in. Thank you. Good question. So consumers, subscribers, same. Ish. Ish? Really? Okay, correct me then, please, because I don't want to tell people the wrong thing.
There's a producers, consumers is you have producers pushing into the queue, and then consumers, only one of them gets the message. With publishers and subscribers, you can have multiple subscribers, and they all get the message. So it's like
okay, I didn't know about the terminology difference. So for the benefit of the stream, and if I repeat what you said wrong, please tell me. So in a producer-consumer model, when a consumer pulls a message off the queue, it's just the one consumer, right? Whereas as a subscriber, you can have multiple subscribers, basically working with the queue to pull messages off. Cool. So I did not know that. Thank you, Gordon. So please remember that and not what I said before it. We're actually going to demonstrate the difference between consumers and subscribers during the practice part. I just didn't know the terminology difference, so thank you. So then, moving forward, another thing about message queues is that they can route messages, right? So you have all these different producers, you have all these different consumers. How does the right message get to the right place? Well, a message queue allows you to route messages by saying, hey, this type of message goes there, this type of message goes there, that other type of message goes there, okay? And we're also going to demonstrate how that works. And a big thing is that the messages are sent in order. This is very, very important, especially because, and we'll talk about this more at the end, finance applications often involve message queues because they guarantee that messages, information comes in the correct order. For example, if you got paid today, right, to your bank account, you want to make sure that your payment comes in before you make a big giant purchase, before you buy something that's very expensive. Because if these get switched, suddenly you've overdrafted your account, right? Or maybe you can't make the purchase or something. So a lot of financial institutions use message queues to ensure that data comes in the correct order, and because money is important, okay? And then another thing is that they can persist messages, right? So one of the things with message queues is that they kind of ensure a little bit of redundancy. So let's say that the consumers or the subscribers are not able to receive the messages or fetch the messages. The message queue can kind of hold on to them for a little bit until the receiving service is ready to take them. Okay, now that's a big thing for distributed systems. That's a big thing for scaling. So that's another huge advantage of message queues. That said, you don't want to abuse it. They only have limited capacity. But it does allow for a little bit of redundancy and safety. I don't know why I wrote that there. So any questions about this part? Does that all make sense so far? Cool. All right, so going forward, when should I use a message broker? Basically, this thing sounds cool, but you could also just, make an API call to a receiving service, right? Why do you need a message broker in between? Well, one major argument is if you're doing a microservice architecture, where you have maybe an order service and a user service and an inventory service, if you're doing an e-commerce platform, right? Maybe you want to kind of decouple these services from each other, right? The services don't need to know the exact APIs of the other services, right? They can just provide the information that needs to get sent, and then the other service can just figure it out. Okay, so it's kind of a way to decouple and kind of remove the need for a contract between microservices, or at least reduce the need. They do still need to agree what data gets sent between them, but it allows for a little more flexibility. Another thing is extreme throughput rate. Message queues are fast. They are super fast. And this is useful because this allows you to do a little bit of buffering, because chances are that your message queue might be receiving messages faster then your receiving service can work with those messages, right? So the message queue can kind of act as a buffer until your receiving service is ready. I mentioned this before, but just reiterating. Another thing is kind of tunable scaling, right? So when we talk about, or is anyone not familiar with horizontal scaling? It's okay to raise your hand. Okay, cool. So horizontal scaling is the idea of I have some service, right, and it only has so many servers, right? Maybe it only has 5 servers. But the amount of traffic I'm getting, those 5 servers are not enough to handle all the traffic. So what I can do is I can spin up a 6th server, and maybe a 7th server, an 8th, 9, however many. And this is called horizontal scaling, or scaling out, okay? So often when we do scaling, we base it off of the receiving services, CPU, memory, all these different resource usage. Another way that you could base it off of is kind of the upstream service, right? So if you know that, the receiving service tends to have problems when it processes more than, 100 transactions a second or something, then you want to scale out before you get to that point. So what you might be able to do is monitor the message queue. And when the message queue reaches too many messages in the queue, basically when your buffer gets too big, okay, start scaling out so we can go through faster. Okay? So that's an alternative to CPU and memory-based scaling. If you're not super familiar with scaling, if that was all Greek to you, don't worry about it. That's more of a systems design thing. That can come later. Next thing is load balancing. When we're doing... if you're just using kind of service discovery stuff, like let's say you're doing a Kubernetes cluster or something, maybe your load balancing is set to round robin, right? Just keep sending it to each one over and over again. But when you send messages to services like this, you're not really accounting for how overloaded that service is, right? So let's say you have like 3 servers that are receiving messages from some other service, and it's like A, B, C, A, B, C, A, B, C, right? This kind of round robin style. But maybe B just got a whole bunch of kind of messages, work requests basically, that are really CPU intensive. They're a lot of work to do, right? And maybe A and C got a lot of really easy work to do. So then B is like working super hard, and A and C are just like, yeah, we're just chilling. This is easy, right? Where what could happen then is your B server starts slowing down, right? And then your users might be like, hey, why is the service slow? And then when you go check it, the service is fine. Because the users who were complaining, they hit server B, whereas when you were testing, maybe you hit server A or server C, right? So this is a problem with round robin based load balancing, which is very common when we do infrastructure things. But with a message broker, where instead of something pushing data to the services can pull something off of the queue when they're ready, that can help things be a little bit more balanced, because then they'll just pull data whenever they're ready, okay? They won't have data forced to them. And that way stuff kind of balances out a little more. Does that make sense so far? Also, for those of you who English is not your first language, if I'm speaking too quickly or if I'm using too complicated of words, please be like, hey, like chill out a bit. And I'll be like, okay, all right? Because I get excited about this stuff. I like to use big words, and that's not always good for understanding. So please tell me if you don't understand, otherwise we're wasting time. So another reason you might want to use message brokers is when you need to ensure that a service has received a message and make sure that you have not sent it more than once. Okay, so again, this is useful for like a financial institution, right? So let's say like your bank account service, like your bank account basically, if you send a message like, hey, we should charge you Menwan, like $10 or something, you don't want that to send twice, right? Because you don't want to pay twice, you only paid once, right? So if the message gets sent twice, well, you just got money stolen from you for no reason, right? But you also need to make sure that the deduction, taking that Menwan from you to pay for something, you want to make sure it actually happened, right? Otherwise, you didn't actually pay for the thing. So message message brokers can help you ensure that the message was received, right? Because there's an acknowledgement of receipt from the consumers or the subscribers, and to ensure that you sent it only once. And this basically makes sure that everything is stable, everything is secure. Does that make sense? That one might be a little tougher to understand. Good. Cool. And then another thing is when you have limited consumers, maybe you're not doing cloud. Maybe you're in an on-premise data center and you only have like 10 servers. And that's it. You're not getting more servers. There is no scaling out, right? You can use a message broker to kind of, again, act as a buffer and help keep those servers from basically getting crushed by load from messages coming in. And the message broker can just be like, hey, I'll just hold on to the messages until you're ready to process them, right? That's kind of more basic example, hopefully less common, but never know. In smaller startups, that might be more common where, they don't have money. So questions about this stuff so far? What's up?
I'm either confused that whether a message broker ensures a message is sent or a message is executed well.
So that is kind of up to you. So the question was, he's a little confused if the message broker ensures that the message was sent or that the work was done well. I'm going to ask you to wait for me to answer that question, okay? Because I think I'm going to answer it in a little bit, but I'll remember it. And if I don't answer it properly, then I'll check with you and be like, hey, did that answer your question? But yeah. So any other questions then? No? Okay. Good? All right. So now what types of message brokers are there? I kind of wanted to remove this slide. There's really two main kinds. There might be others. But the two main kinds are, and this is related to what Gordon was saying with the consumer versus subscriber thing. There's point-to-point, where you have from the point of the message queue to the consumer. Or there's like the publish-subscribe model, where some publisher can push messages to the queue, and then n number of subscribers can pull off of the queue. The point-to-point is more for the buffering purposes, and publish-subscribe is more for when you need more complex routing, when you want more scaling, these kinds of things. But most message queuing services can do both of these, so you don't really need to think about it too much, because you'll just naturally do whatever is necessary. And that's kind of why I wanted to remove this slide. I'm not sure it's really helpful, but there's two types. You know how they work. One is just one-to-one. The other can kind of fan out and work with a whole bunch of copies of messages and all this kind of stuff. If it doesn't make sense, this part what's up?
So the big difference in how we end up using them is, so one of them we kind of use as a queue with potentially multiple consumers. Well, the same consumer but scaled out. And then we're doing competing consumers so that one of them will get the message and they're all like trying to quote, and then one of them will succeed, get busy, and then the others will quote. So it's like the horizontal scaling thing. But only one of them is getting the message. The other is the more like pub sub, where it might be different services, like different code.
I see.
It's doing very different things. It's just listening for the events and could be anything. So it's for like more decoupling.
Yep. Okay. So to explain for purposes of the stream, when it comes to point-to-point, that's kind of the consumer model where you have, when we say consumer in this case, we don't mean like a single server. We mean like a single service, right? That might consist of multiple servers. But this service is pulling the message off and doing the work. Maybe it'll scale out for performance purposes, but it's just one service consuming it, and then it's done. Whereas the publish subscribe is more, you might have multiple services pulling messages off to do different operations. Is that a good summary of what you said? Okay, cool. When we do our example, we're going to do more of the publish subscribe style than the point-to-point style. Okay? So any other questions before we go on? Cool. So, on to the more practical stuff. What is RabbitMQ? What is the software we're actually going to be working with today? Well, according to their webpage, they say they're the most widely deployed open source messaging service, or message broker. I don't know if anyone has actually checked that, but it is very popular. It does support point-to-point and publish-subscribe models. You can do both of them. There are open source and commercial versions. It is owned by Broadcom, which is really weird. Who knows Broadcom? Okay, kind of the people I expected to know Broadcom. So chances are you have a Wi-Fi chip in your notebook. There's a high likelihood it's made by Broadcom. But why does a hardware manufacturer own a message broker software? Corporate nonsense. So it was originally an independent company, then VMware bought it, and then Broadcom bought VMware. But in any case, there's an open source version, there's a commercial version, you're good. I just thought that was some fun trivia for you guys. And it does have support for most big languages. So it supports Python, Java, PHP, Ruby, Erlang, awesomely enough, .NET, and I think it supports Go too, if I remember correctly. But it has support for lots of the big languages, and it's written in Erlang. If you're not familiar with Erlang, it is a functional language, and it is stupid fast. It is super fast. What's up?
When you say it supports, you mean like
It has
libraries
clients.
for the consumers and publishers to use so that they're not directly... Okay.
Right. So thank you for the clarification. So Gordon wanted to check what I meant by kind of support. What I mean is they have libraries that they have kind of officially supported libraries that allow your software to act as a producer, publisher, or a consumer subscriber. So that's what I mean by support. Cool. So any questions about this part so far? Cool. We're almost into the fun stuff, I promise. So now, kind of getting a little more nitty-gritty. What are some of the concepts in RabbitMQ that we need to know in order to effectively use it as a message broker? First, there are exchanges. Okay? When you are writing a client, in this case a producer or publisher, you want to create an exchange on RabbitMQ. Okay, so you connect to RabbitMQ, and then you say, hey, create an exchange. You can think of an exchange kind of like a router. Okay? Exchanges, there's different types of exchanges, okay, with different behaviors. And you can configure the exchanges to send data to certain places based on certain criteria of your message. That sounds very vague, but we're going to demonstrate it in just a couple of minutes. Now, we're only going to cover one of the types of exchanges. We're going to cover a topic exchange. Yeah, is it warm in here? It's a little warm. Okay, because I'm a little warm too. All right. Yeah, can you just kill it? Thanks. Yeah, because by the time it cools down, it's going to be time to go. So, yeah, thank you. Right. So we're going to try the topic type of exchange today. There are other types of exchanges that RabbitMQ supports, like fan-out, direct, all these kinds of things, but you can read the documentation for that. We're just going to do a kind of beginner to intermediate kind of example. And then the next thing are queues. The queue itself, where the messages actually get routed to, and then they act as the buffer for consumers or subscribers to pull the data off of. So the exchanges, they get bound to the queues. When you create a queue, you say, hey, queue, talk to this exchange in order to receive messages. Okay? So that's a key step. You have to bind a queue to an exchange in order for that queue to get messages. Well, that's not 100% true. You can just use a queue, but we're not going to cover that today. And then I keep mentioning this routing stuff because it's a really cool and powerful feature of message queues. RabbitMQ has the concept of a routing key, where you can say, hey, this message has this kind of marker, all right? This marker we call a routing key. And the routing key is just some text, all right? And it's some text with dots. So it's kind of a dot delimited thing. So you can be like, you know, service.web.english or something like that, right? And that kind of establishes a hierarchy. And then you might have, you know, kind of a public service versus an internal service. You might have web services versus like data services or machine learning services or whatever. And then you might have multiple languages like English, Korean, Spanish, Chinese, whatever, right? And by having these routing keys, you can say, hey, I want this queue to, let me make sure I'm getting this right. I want this queue to take a message from the exchange when the routing key matches something, right? So let's say that we had, a translation service, a localization service, okay? And we wanted to capture all messages in English to translate them to other languages. We might create a queue for this, and we might say, hey, accept any service, whether it's web or data or whatever, but give me everything that's English. And then any messages that come in that have English get routed to that queue, and then your service can pull them off and do stuff. Okay? Does that make some amount of sense? A little bit? It might make more sense when we get to the code. And then, to answer your question now, it also has the idea of acknowledgement. So when you acknowledge a message on a message broker, it gets marked for deletion. You basically told the message queue, we're done with this message, you can get rid of it. Okay? That is acknowledgement. And there's a couple of ways you can do this. You can set messages to automatically be acknowledged when you pull them off the queue. So basically, as soon as it gets pulled off, it can be deleted. That's the automatic acknowledgement. Or you can have your consumer or subscriber explicitly say, okay, I acknowledge this, you can delete it now. So does that kind of answer your question then? Cool. Now, as for which one of these you want to do, it depends on your use case. Just make sure that if you do have a delay between when you consume the message and when you acknowledge it, that another consumer or another subscriber or consumer doesn't also pull the message, right? Because then you get it sent twice, and then you can have all sorts of problems. So you got to be careful. But we can talk about that later. So any questions about these concepts within RabbitMQ? What's up?
Can you talk a little bit about the different types of exchanges and what are the differences when you use which one?
Sure. I'll have to look at the documentation for one of them, but I can explain at least 3 of them from memory. We'll have to look up the last one in a second. But for RabbitMQ exchanges, the most basic one is fan out, which is for every queue that is bound to the exchange, it'll just send the message to every single queue. Okay? So going back to our example earlier of web services with languages and stuff, regardless of whether it's a web service or a data service or an English service or a Korean service, whatever, if the queue is subscribed to a fan out exchange, it's going to get every single message, period. Okay, so that's fan out. And for people where English is not their native language, fan out is the idea of you have something come in, and then you know how you have those folding fans, right? It kind of goes from a single thing to this broad cone kind of shape. Well, not cone, but you know what I'm trying to say here. This arc, there we go. That's kind of fanning out. One comes in, but it gets distributed to everything downstream. That's fanning out. So that's one type of exchange. Another type is direct, where basically you say, hey, this queue is directly subscribed to this exchange, and so just send messages straight through. Wait, that might be wrong. Wait. No. I'm sorry, that's a mistake. No, that is right. Let me check. Let's check. Let me not tell you the wrong things. Also, I didn't full screen this. What the hell? Okay, give me a second here. Let me grab my... Here we go. Nope, that's not what I'm looking for. There it is. All right, so this page is linked in the presentation, which I'm going to share later. But if we go down to, there we go, direct exchange. Okay, yeah. So basically,
Sorry, Beege, could you zoom in a little bit?
sure. Oh, can we collapse this? Of course not. But anyway, that's right. That's what it is. That's what it is. Okay. So for a direct exchange, it also uses a routing key, but it requires that the routing key be an exact match with a queue. Okay? So now the routing key, I don't remember no, I did mention this earlier, but I'll repeat. When a producer or publisher sends a message, they also apply a routing key to that message, right, to help the message queue understand where to send it. Okay? So, excuse me. Yeah. Pulling up my notes again. So, the routing key is basically just an exact match. Okay? The direct queue is an exact match for a routing key. And then the other two types are the topic exchange, which is what we're going to do in today's example. Okay, and this is more the publish-subscribe model, like Gordon was mentioning earlier, where you can have kind of wildcards for your routing key. So remember earlier I said the service, web, English kind of thing? You can just have star instead of web. You can have star instead of service, and then you can say English. That's kind of topic-based routing, okay? So you can say, hey, I'm only interested in the English topic. I don't care what the other bits are. And then they'll route that way. So that's a topic-based exchange. Sure. Say one more time?
What happens if you have another key? Like if you want to add extra one more key, is that going to send it to the first one?
It won't get sent. If it's not an exact match, it won't get sent to any queue. So the question was, if you send a message with a key that doesn't have a corresponding queue when you're in direct exchange mode, what happens? It doesn't get sent anywhere. So.
What do you call the thing that you send? Is it a message or an event, or what's the terminology?
I believe it's message.
Can a message have only one routing key, or can it have multiple?
A message, I believe it's only one routing key. Let me double check. Where is it here? No, why did you send me all the way over here? Huh. Okay, so, let me just check a different way. Give me 1 second here. I'm on the wrong branch. Crap.
Sounds like a job for GPT.
So, yeah, I don't know if I have it. I don't remember my GPT account. But yeah, let's ask real quick, because that's going to be faster than searching through all the docs. Let me not show everyone my email address and such. Or at least my personal email. There we go. Yeah, that's fine. I don't care about anyone seeing that history. So, in RabbitMQ, can a message have multiple routing keys? Multiple routing keys. And let's also make this bigger so people can see. I'm pretty sure the answer is no, but let's see. Yeah, it can only have one routing key. So if you need a message to be delivered to multiple queues with different routing keys, you would typically publish separate messages with different routing keys for each queue you want to target. However, I would argue that it might be better to just make your routing key more complex and to use a topic-based exchange rather than send the same message twice with different routing keys. But yeah, what's up?
So there are different types of exchanges. A queue can be bound to an exchange, and a queue can be bound to multiple exchanges.
Yes, a queue can be bound to multiple exchanges.
And are there different types of queues, or is it just the type of exchange that determines how the queue behaves, and queues are all the same?
So I haven't gone as deep into that part. The different types of queues are more advanced, and I'm not sure in what ways. So the short answer is I don't know.
Is it correct to say that you send a message to the RabbitMQ, you're sending it to the exchange,
Yes.
and then the exchange is deciding you don't send it directly to the queue?
So there is a way to directly send it to a queue, but it seems like that's not really used very often. It seems it's only shown for demonstration purposes. Yeah. Cool. All right, any other questions about routing keys?
Can each exchange only be one type?
Yes. An exchange can only be one type. Any other questions? What's up?
Is it possible to make like a channel type of subscribe, publish and subscribe model that Redis uses? For example, in Redis, when your user pops up, it creates a channel, and the publisher doesn't know if anyone subscribed to that channel, and there can be like multiple subscribers.
So that's the same in RabbitMQ. So the question was, also, I might have missed the other questions for the stream. I'm hoping that my explanations covered it. But the question was, in Redis, for example, which also has a publish-subscribe model, the publisher doesn't have any awareness of the subscribers. Does RabbitMQ have something like that? And yes, it behaves the same way when you're using a topic exchange with the routing keys and all that kind of stuff. I believe the direct exchange works similarly, except it's an exact match rather than more fuzzy stuff, but yeah. What's up?
Why would you use RabbitMQ versus Redis?
So the question was, when would you use RabbitMQ versus Redis? I'm actually not sure. So go ahead. Yeah.
I think it's better because it is persistent on the disk instead of Redis, where it's only memory. So if your like RabbitMQ service just goes down, you can still retain the data. But when the Redis service goes down, evaporates because it's in RAM.
I think Redis does support a persisting to disk mode. Yeah. So both Redis and RabbitMQ have a publish-subscribe model. Both can persist to disk. Both can support clustering. In terms of performance, I'm not exactly sure. In terms of any special features that one has that another doesn't have, I'm not exactly sure, except I know that Redis does support features and functions that are not only message queuing. Like you can just use it as like a key value store, kind of like as a caching layer. But I'm not sure beyond that. So unfortunately, I'm not sure. But if we have time at the end, let's search around the internet and see if we can find the answer together. Does that sound good? Cool. All right. Any other questions? All right. So going forward. Okay.
I just looked it up.
Okay, cool.
But this is just my guess, but like RabbitMQ initially it was designed as a message handler, right?
Right.
Right. So it uses something called advanced message queuing protocol.
Yep.
Which supports complex routing logic, and apparently in terms of message size, RabbitMQ can handle larger amounts of messages, right? Compared to Redis, because it's designed for having messages on the line. Whereas Redis was initially designed as a key value store.
Got you. Okay.
So it can handle large amounts of messages more reliably than Redis.
Okay. So Jay did some quick searching while we were discussing, and something he found online is saying that RabbitMQ was designed from the very beginning. All right, do you want to interrupt or do you want to wait until I finish? Okay. RabbitMQ was designed from the beginning to be a message queue, whereas Redis was originally designed to be as a key value store, and then they realized, oh, hey, we could also do a pub-sub message queue with this, so let's add that in. Additionally, RabbitMQ supports a larger message size than Redis does. So, yeah.
So he mentioned
Yes.
AMQP.
Yeah.
Yeah, the RabbitMQ docs are like they heard with that acronym AMQP will show up like all over.
Yep.
So yeah.
So
Like the protocol.
yeah. So I apologize. I'm not doing great with terminology today. So all this stuff that we've been explaining with regards to like exchanges, queues, routing keys, acknowledgement, this kind of stuff, this is all part of the AMQP model. So basically what I've been explaining is AMQP. Okay, so as for the 091, I don't know where the hell that came from. I remember I Googled it a long time ago and found the answer, and then found it was not really important and promptly forgot about it. But yeah.
Is RabbitMQ just one implementation of the AMQP, and are there others?
Correct.
That I would have heard of?
Yep. So the question is RabbitMQ the only implementation of AMQP? And if not, are there other ones you may have heard of? And yes, it is an open source protocol, and I believe there are other implementations of it. Yeah, here we go. So basically, Cupid, ActiveMQ, Azure Event Hubs. Where's Rabbit? Okay, here's pre-AM1QP. Whereas if you want the newer version, you have to do it via plugin, but that's fine. The plugins are pretty lightweight, so yes. Does that answer your question? Cool. Other questions? Cool. So, any final questions before we get into actually doing some stuff? All right, let's go. So, to do the actual workshop portion, good, we have an hour to do it, so that should be enough time. We're going to do the fun part. We're going to accomplish 3 main tasks today, okay? We're going to work on setting up RabbitMQ itself, but we're going to do a very, very basic version, so that part's going to be really short. Then we'll work on a publisher. We'll work on producing messages and pushing them to an exchange. And then we'll work on a subscriber. I used the wrong terms. Thank you again, Gordon, for correcting me. We'll set up some subscribers to consume messages from these queues and do stuff with them. Now, the example we'll be using is kind of a greeting card service, like a calligraphy greeting card service, where you say, "Hey, I want a custom calligraphy greeting card," and you can choose like a language, and you can choose whether you want it to be digital or physical. And that's kind of the example we're going to go through. It'll have a billing service, and it'll have the kind of calligraphy design service. Okay? So, that said, go ahead and open up your editor of choice. We did recommend Visual Studio Code just because it's free and most people have it already. But it can be whatever you want. And there is a repository you want to clone. Let me make this bigger for you. Whee! There we go. Oh crap, give me a second. I don't have it in my copy paste buffer. What? What? Oh no. Ah. There we go. You want to clone down this guy. Except let me make it proper so you don't need to log in. Ah. What is going on? There we go. So yeah, you want to clone this guy. I don't know why it's cutting off of the G, but if you're on Discord, I will also paste it in the Discord. Give me just a second here. Why is my brain not parsing information quickly enough? There we go. Cool. Oops. There we go. There you go. So you guys can clone that down. So let me do that real quick. Cloning, okay. And then we're going to go into that and then we're going to open that directory. Menu, file, open folder, projects, intro to RabbitMQ. Here we go. This is too big now. There we go. Can everyone see this okay? Cool. All right, so before we get started with actually writing the code stuff, I want to explain to you what the hell is even here, okay? So, you know, we got README, license, all that sort of good stuff. I already set up a Docker Compose for you, okay? Why is this? Okay, let's get rid of this for a second here. So I already set up Docker Compose, okay? You don't have to do anything special for it. This Docker Compose sets up a RabbitMQ server for you with the management plugin. The management plugin gives you a web UI that you can look around and click on stuff, okay? So we're going to do that. And then I've also set up all the ports. I've set up a health check, all this kind of stuff. All that's done for you. And then I created services for the producer and consumer, which, again, I really need to rename publisher and subscriber. But I've set all these up for you. They're set up to run only after the message queue is up and running. And we're going to have them automatically build based on our code. So all that work is done for you. You don't have to worry about that, okay? In terms of development, I've already set up the Docker files. I've already set up the dependencies, all that sort of good stuff. You don't have to worry about any of that. It's done for you, okay? So we're going to focus on the code for today. So, what has everyone who is going to follow along cloned this down? Everyone has this? Cool. So what you should be able to do is, if you have, nope, that's not what I'm looking for. That's what I'm looking for. If you have Docker installed, things are already complicated because Docker recently did a big upgrade. Depending on what version of Docker you have, we might need to make some small changes to our Docker Compose file. If you're on the latest version of Docker, you can follow along with this. If you're not on the latest version of Docker, you're going to hit an error and then just kind of wave at me and I'll help you fix it. Okay? So if you're on the latest version of Docker, you should be able to do Docker Compose up. No dash between Docker and Compose. That's the old style. Okay? The new style is just like this. And you'll see all this is all RabbitMQ stuff. And a little bit more, I think. Yeah, there we go. Okay. So now RabbitMQ came up, and the images that I created for the producer and consumer, or publisher and subscriber, all they do is they print hello producer, hello consumer, just to kind of show that it's working, okay? So at this point, RabbitMQ is up and running, okay? Does everyone see something like this? Actually, you probably have to wait a little bit because it's probably pulling down all the images and it's going to take a minute. But did anyone hit an error on this? I see one look of consternation. Everyone got to this point? Or is on the process of getting to this point? You didn't get a Docker Compose error? Good? Cool. Still pulling? Okay, but that means that it parsed Docker Compose properly, so you're okay. All right, great. Apparently I was the last one to upgrade. So, if you're here, or if you're pulling, you can catch up in a second. RabbitMQ is running, and it's running with the management plugin, which gives us a user interface. So if we go over to our browser, I have way too many tabs, and we open up a new browser tab, and we go to localhost :8080 Pashi. Okay. I'm already logged in. I want to. How do I log out? You will get to a page like this. Okay. The default username and password are both guest, so you can just do guest. Okay. And at this point, yeah, it's fine. It's fine. Go away. You can see the RabbitMQ management interface. Okay. Who's still pulling? You're done pulling already? Ooh, fast network is fast. Okay. So, at this point, RabbitMQ is running. We can see that there are exchanges. We can see that there are queues and streams. You'll see channels. Channels is kind of like a sub-item of connections. You don't need to worry about it for now. But we're going to kind of interactively through the web UI create an exchange, create a queue, and we're going to actually send a message and see that we can pull the message off of the queue. Okay? So let's click exchanges up here on your web UI. And these are all the kind of built-in exchanges, but I want to show you guys how to do it yourselves. Now, granted, in the real world, you will never do this because you should be doing all this stuff in code. But this is just for demonstration purposes, okay? So we'll add a new exchange. We're going to call it intro. You can call it whatever you want, but I'm going to call it intro, and if we all call it the same thing, it's less likely for mistakes. Now we're going to do direct. Okay, I'm not going to bother. You can see direct, fan out, headers. Oh, we didn't cover headers. I'm sorry. That was the one that we pulled up the documentation to look at, and I forgot to look at it. But it doesn't seem very popular anyway, and you can look it up on your own time. But we're going to do direct. Durability. Earlier we were talking about the difference between RabbitMQ and Redis, and we talked about persisting to disk. If you set an exchange as durable, what it means is that when it receives a message, it's going to write it to disk to make sure that if RabbitMQ goes down for any reason, it doesn't lose the message. Okay? It's written to disk so that when it comes back up, it can just read it from disk, put it back in the queue, and go. Now, there's a performance trade-off when you do that, because writing to disk takes time. But if the safety of the data is more important than how fast things go, then it's an easy decision, right? In this case, it doesn't matter. We're going to blow it all up in a minute anyway. And then auto-delete no, internal no. You can click the question marks there if you want to learn about it. But for now, you can just hit name intro and hit add exchange. Once you do that, it shows up in the thing right here. You're good. You can click it. You can see info, whatever. Everyone good on that? Cool. So congratulations, you've made your first exchange in like 3 clicks. So now, we're going to go to queues and streams. And we're going to create a new queue. We're going to call it test, I guess, right? And that's the only thing we need to enter, okay? And we can hit add queue. Now, this queue is created. It's not bound to the exchange yet. So it cannot, or we could have it receive messages, but it's weird and you're really not supposed to do it that way. So we want to bind it to the exchange. So what we want to do is remember how to do this. I think we go back here. Let me double check. Yes, okay. So from here, you want to go, once you've made your queue, no, that's right. Yeah, once you've made your queue, you want to click the queue. Okay, so now we're looking at our queue named test. Okay, we can see that there's no messages in the queue. Okay, it's an empty queue. We want to bind this queue to an exchange. Okay, so we named our exchange intro, so we're going to just enter intro here. We're just going to leave the routing key blank. Okay, and we can hit bind. So now we can see that it's bound to the intro exchange. Okay? Does everyone understand what we just did there? So far so good? Cool. So now, does anyone need me to slow down?
Yeah, just a little bit, please.
Sure. Do you need me to go back over anything?
Yeah, we got a little bit behind opening up for 8080.
Oh.
We're doing like a port formatting thing. Sorry.
Okay.
I have one question.
Yes.
Why bindings show like two?
Because there's a default, because RabbitMQ also creates a default exchange, and yeah. But I usually don't like to use defaults on things because default has no meaning, right? So if I send a message to the default queue, what does that mean? Don't know, right? So usually I don't use defaults, or I rename them or something. But in this case, when you create the exchange, it's automatically bound to the default. When you create the queue, it is automatically bound to the default exchange. But we wanted to bind it to the exchange that we made. Yeah. Are you guys caught up? All right. Does anyone else need help catching up? Everyone's to this point?
What about logging?
Yes, guest.
Guest?
And then you want to go to exchanges. You want to add a new exchange. Just give it the name intro and hit add exchange. Fixing my posture.
We're keeping it as direct.
Yeah. And then you can go to queues and streams. Under the add new queue heading here, you can just set the name to test or whatever. It doesn't really matter. And then hit add queue. And this is also a chance for anyone else to catch up if they need to, or just for review, right? Then you can click the name of the queue here. You can see there's no messages in the queue. And then down here, you can add a binding. You want to bind it to the exchange intro. And then click bind.
From exchange intro?
Yep. All right, caught up?
I think so.
Everyone else up to this point too? Cool. All right. So now, let's do the actual fun part. Let's go back to our exchange. Let's go to our intro exchange. Okay. Let's send a message. So the routing key, we're just going to leave it blank because we didn't set a routing key for the receiving queue. Okay. And the payload can be whatever you want. You know, CodeSol is typing is hard. Let me make this bigger. There we go. CodeSol is really cool. Thank you everyone for coming. Okay. So now again, we don't have awareness of the queue that this will go to based on the message that's being sent, right? That's all done using the routing key. We just had a blank routing key, so it's fine. So now we can hit publish message. We get notification that message is published. Everyone's good on that? What's up?
So once the message is published, does it sit on the exchange, or is it sent directly to the queue? But what if there is no queue?
If there's no queue, I don't remember how long it sits in the exchange. I don't remember. I don't know if it even sits.
But it disappears.
Yeah, it's gone.
Okay.
Yeah.
Is there any kind of error when you try to publish a message that cannot be delivered anywhere?
I'm not sure. I was only pursuing the happy path for the purposes of the intro. Sorry. That is a good question. And keep it in mind for the end, and we can go look for the answer together.
So,
Yeah.
Are there like valid scenarios where like sending a message to an exchange that doesn't actually go anywhere? Yeah.
That would be very unusual. I can't think of a case where you would want it. There is an idea of a dead letter queue.
I
But-
can think of a case, which is where you're building like a decoupled thing,
Mm.
and your team is just writing the producer,
Hmm.
and you don't really know or care yet who or when it's gonna be subscribed to.
Oh yeah, during development time, yeah.
Yeah.
Okay.
Initially.
So for the benefit of the stream, Gordon asked if there was a case I knew of where you would want to publish messages to an exchange without having a queue ready to receive it. And I wasn't sure of one. He mentioned that it could be useful during development where you are the producing service and you don't know anything about the consuming service yet or the subscribing service yet, but you know that you need to send it to the queue. That's a case during development time. So, or
you might have like a big enough company,
Hmm.
and your policy is just everyone send everything to the. Don't worry about who's consuming it. So even beyond development, there might be things that events that no one needs yet, but
Mm.
they're in the message broker
Mm.
if you do need them.
Mm. Yeah, I could see that. Okay. Another use case is maybe you're in a larger organization where communication time is not so great. And you want to basically make data available to other services, but you haven't figured out which services want to take it yet. So maybe your team can publish some data to an exchange. And then other services, if they hear about your service and they're like, wow, I do want that data, then they can create a queue subscribe to the queues of that exchange, and then get the data that you're publishing. So yeah, that's a pretty good use case too. Although I can't figure out if that would be good communication in the company or bad communication. I could see it being argued both ways, but yeah. In any case, it's a very valid case. So any other questions then, or any other ideas for that one? Cool. I am very glad you're here today, Gordon. All right, so now, so we publish. Oh wait, yeah, we publish the message to the exchange. So now, if we go to queues and streams, and we select our test queue, we will see that there is one total message in the queue, and it is ready. Okay, it has not been read yet. Okay. So now, if we go down here, we can get messages from the queue. If we leave it as default, it will not acknowledge the message, so it'll stay in the queue. Okay? So we can say get message. And there we go. CodeSol is really cool. Thank you, everyone, for coming. Oh, now it says 0 message. Ah, right. So now you will see. Where'd it go? Where is it? What? I can't tell what color this is. Oh, we can see that there was a get. But we can, I think, we can continue. Yeah, we can continue to get the message because it has not been marked for deletion yet, right? But it will tell us that, hey, this is redelivered because it's been delivered once already. Okay? And that's how we can avoid the multi-send kind of thing, is we can check if the message has been redelivered or not. And then if we say, go ahead and automatically ACK the message, acknowledge. When we say ACK in message queuing, it is short for acknowledge. Basically, mark the message as handled and say it's OK to delete. So we can say automatically ACK, get the message. Okay? Again, it looks the same. But now, the message is gone. Because we acknowledged it, we told the message queue, we're done with this message, you can delete it. Okay? Does that all make sense so far? Cool. All right. So now, let's get back to coding. Let's get to Docker Compose here. Control C to tell Compose to stop. Takes a second. Now, I want to clean up all the other exchanges and queues and stuff we created. So just do Docker Compose down just to clean it up. The disk is not persistent. That was intentional because I wanted to be able to clean it up easily. So now it removed all the data and stuff. So now let me pull up my notes here. Why did I do that? Okay. Also, I'm surprised that's allowed. Oh, that's why. Okay. So now in our config here, we have this RabbitMQ.conf. Okay. This RabbitMQ.conf is the default configuration file for RabbitMQ. If we look at our Docker Compose, okay, we have this right here. I commented this out. I don't want to have to type it all again or have you guys type it all again. This will mount our RabbitMQ.config file, this file here, at this location, this etc RabbitMQ RabbitMQ config. That is the default location for the RabbitMQ configuration file. Now you can change this using environment variables and all that sort of stuff. There's also a config.d folder that you can use, but we're not going to talk about that today. But if you just comment out these lines here, or sorry, uncomment these lines here, highlight them, hit Control/. Don't forget to Control S to save. What it will do is it'll take that RabbitMQ config file and put it into the RabbitMQ and mount it into the container. There we go. We're doing good on time. So now we can actually do stuff with this RabbitMQ config file. So you might be thinking, cool, but what can we do? And I had to pull up my notes here. There is a web page. Or sorry, there is a, nope, that's the wrong thing. This is the thing. Here we go. There's, RabbitMQ has an example configuration file. Let me make this a bit bigger. Okay. So this is an example file, okay, of the common configurations that RabbitMQ allows, okay? In a different branch of the repository, I'll talk about the branches at the end and how you can use them. I have this link, so you can find this later, okay? But we talk about basically what port do you want RabbitMQ to bind to? Okay, if you're using Docker, it's not that big a deal, but if you're doing some kind of on-premise bare metal stuff, this is important. You can also, if you wanted to bind to a different IP address, you can do that. If you want to enable SSL, basically to do encryption to and from the message broker, you can do that as well. You can set basically how many Erlang processes. So Erlang, I believe, someone correct me if I'm wrong, I'm not an Erlang person. I believe Erlang runs in a virtual machine, and so it has its own processes that it manages, and so that defines like how many things it can do simultaneously. So you can get down into the Erlang configuration and change this kind of stuff. It also has timeouts. So if you're having some producer or consumer trying to connect to RabbitMQ and then maintain their TCP connection, you can have a timeout to say, hey, I haven't heard from you in a while. I'm going to assume you're disconnected. You can also do reverse DNS lookups if you have DNS configured so that you can see maybe in the logs who is connecting, who is not connecting, this kind of stuff. And then there's all sorts of access control stuff. So you can say, hey, I only want certain users to be able to connect on the local host, or various SSL configurations, or what else was in here? Where was it? You can also set authorization backends. So if you want to use LDAP, let's say you're using LDAP as a central login service, you can configure LDAP configs here too. So that's all really nice for like monitoring and operations and that kind of stuff. But for our purposes, there's not a whole lot in here that we're going to use for today. The big thing or the only things we want to try are, oh, I didn't actually test this. We'll do it live. So we can set the cluster name, right? And we can set it to something like org.codesol.infra.rabbitmq. You don't have to do this. You can make it whatever you want. But you can do these kinds of configurations. You could also maybe set reverse DNS lookups to true. What is this? Oh, geez, I haven't even thought about them in a long time. That is not the word true. That is the word true. So you could do these kinds of configurations, and RabbitMQ can pick them up. What's up?
So would the exchange and the key setup that we kind of did manually before, is this where you would?
It is not, actually.
Okay.
Yeah. Or, oh. So I messed up. There is the concept of an AMQP schema. And I remember finding it and being like, oh man, I have to go over that for the intro. And then I promptly forgot about it. So there is, let's take a quick look. Too many browsers. Nope, that's the wrong one. That's the right one. Schema definition, import and export. So okay, so this is for permissions. So there is an idea of a schema. I don't know exactly what it is. I know that it's some kind of configuration that you can import and export and all this kind of stuff. I don't know if it's only off. I don't know if it includes exchanges and queues. I'm really not sure. In practice, I don't think it's terribly useful because your clients, whether they're producers or consumers, should be doing the creation or should create or at least ensure creation of exchanges and queues anyway. Just to make sure that they subscribe to the correct thing or that they send messages to the correct thing. But I'll show an example of that when we get to the producer and consumer. But it may be worth looking up schemas. I apologize. I missed that during my preparations. So yeah. But yeah, does that? Cool. Any other questions? Cool. So now let's go ahead and try to run this again. Let's do a Docker compose up. We should not need to rebuild because it's just a volume mount. So if we do this again, I didn't actually test this part though. I missed that during my preparation. Does it say the thing anywhere? So, I don't think it does. Oh! I don't see the cluster name anywhere in here, damn it. Oh well,
You try searching for it.
does this support search? Oh, it does. Aww. Oh. Aww. Maybe it's in the web UI. Wrong thing. Oh my god, there's too much. Here it is. No, here it is. Refresh. Oh god. Oh, it didn't work. Oh no, why didn't it work? Well, this is why you should test things, boys and girls. I'm actually not sure why that happened. That's strange. Let's see if we can. Okay, that's fine too, I guess. Huh? Oh, okay. Oh no, because that's going to be... Oh, did I just kill it? Oh, I killed it. Oops. Crap. Oh well. I'm not sure why that didn't work. Oh, I know another way to do it. Hold up. Let's try that again. Let's get you to come up. We can do it here. Fun little Docker things. So if we look at MQ here, we click this guy, there we go. So now, okay, that's all up and running. Execute, here we go. Huh. Oh.
Well, you might want to get rid of the trailing slash.
I know what happened.
Says
Ah!
Yeah.
Oops. Okay, that's why it didn't work. I'm sorry, guys. There's a bug in the repository. It should not be config. It should be conf. Because on my local example, I was like, why is there this folder? Because Docker was creating it because I entered the wrong thing. So here we go. Sorry about that, guys. So if you make this change in the Docker compose file, you change source and target to be conf instead of config, it should work. I'm sorry about that. That was my mistake. So let's kill this. Yeah, we're okay on time still. Run this again.
It's really strange because my Docker compose just didn't want to start because of the because there was no file called RabbitMQ.config.
Ah, well that sounds like it was protecting you in that case. Also, I feel like there's so many different versions of Docker at this point. All right, so now if we go back to our web interface here, wrong web interface. There we go. Okay. It's about to be like, come on, do I not know how file systems work? Yeah. So there we go. So that's just a small example of, you know, changing the configurations. You have that RabbitMQ.conf. You put in the Etsy folder or Etsy RabbitMQ folder. Yay. Good. Not the most exciting part, but just demonstrating how to do configuration. So, what am I doing next? Next is, let's just clean up some stuff here. So that's it for the UI for now. We're going to do next, excuse me, is, I need to pull up my example here, otherwise this is going to be an absolute train wreck. All right, now, actually no, we will want the web UI in a minute, but one step at a time. So now we can get the cluster up and running. That's all good. Now let's actually let's create an exchange and let's push some messages to the RabbitMQ cluster. Okay? So let's go ahead and open the producer folder. We can go ahead and kill Docker for now. And come on, man. There we go. And let's go ahead and go into the producer folder. Okay. Now, I wrote like some Python-y stuff. What you want to do is create a virtual environment. So you want to do this python-m VM. And since we're using Visual Studio Code, if you do .vm, Visual Studio Code will recognize it. Okay, and then you want to source that. Source.vm/bin/activate. Or you could just do Control-Shift-P. You could say, you could just do it this way. You could do Control-Shift-P, create environment, VM, whatever interpreter you want, and then it'll create the environment. Oh, actually, no, you don't want to do that. You don't want to do that. Sorry, guys. You don't want to do that. Because that'll create it at the root, but I want it to be... Actually, I guess it doesn't matter too much. Whatever. One of the two should work. So now, once you have this, if you make sure you're in the producer folder, you can do a pip install -e dot. This is newer pip things if you're not used to like the newer pip things. If you're used to the old way of doing things, this might be like, what the hell, install dot? What is that? -e puts it in edit mode so that instead of like doing an actual pip install, it just does symlink references to your current project directory. And then dot means the current directory. What this will do is it'll read this pyproject.toml, and it'll look for your dependencies, it'll look for your build system, all that kind of stuff here. So that's what pip install dot does. It looks for pyproject.toml and then does what it says there. I've configured all that stuff for you. You could just do this, okay?
Is that source command the one that we didn't want to do, or was that one okay?
The source command is okay. It's the stuff I was doing in the UI that was not okay. Yeah, don't trust me on a UI. On a terminal, you can trust me. On a UI, don't trust me. All right, so we'll do this. It installs Pika. Pika is the official RabbitMQ client library for Python. You can upgrade pip if you want, but yeah. And then we can open our main.py and we can start coding. So now you saw the hello producer message. This is where it was coming from. Okay? Sorry, am I blocking you? There we go. All right, so has everyone gotten to this point now? So far, so good? Cool. So now let's go ahead and let me get my example here, otherwise it's going to be a train wreck. Oh, no. Okay. Oh, okay, great. Yeah, it'll be okay. Yeah. So, those of you with more experience, I might need your help to make sure people can keep up. Okay? So, what we're going to do, first off, we're going to be using Pika to do stuff with RabbitMQ. So let's go ahead and import Pika. Okay? And then we can get rid of this hello producer thing. And just to make sure that stuff is okay, I just want to print that we're starting. Okay, just some nice little debug stuff, right? And then let's go ahead and initialize our RabbitMQ connection. So we're going to create a connection object, and we're just going to do a blocking connection for now. Okay? Did I type it right? I did. Blind typing is great. Okay. So give everyone a second to type this, and then I'll explain what the hell it is. Okay, please give me some kind of signal to let me know that you're caught up. Cool. Cool. All right. So, you might be wondering what this connections parameters thing is. This is just basically the parameters needed to connect to RabbitMQ. They're all optional except for, I think, host. In this case, the host is MQ, just because in our Docker Compose, the service name is MQ. So Docker Compose sets up a DNS entry for MQ. So that's it. That's a little bit of magic there. Okay. So this will establish the connection to the RabbitMQ server. Okay. Next, we want to create a channel. As for what a channel is, that's more advanced than I want to. What's up?
So the blocking connection, you want to talk about that a bit?
Okay. So, and the blocking connection. Why is it called the blocking connection? A lot of times when we're doing network stuff, you have blocking, and then you have like asynchronous. Blocking being synchronous. We're just doing blocking connection because we're not writing a super high performance thing. We want our application to stop and do the connection. There are other connection methods, but I haven't really looked into them. There is other stuff. Do take a look at it. If you look at the parent package, you can see. God, I hate this about VS Code. I miss PyCharm. There are other types here. Let's do it this way instead.
So I've done stuff maybe like this in Redis with like the blocking paths. I don't know if it's the same thing. And the difference is the blocking one, just the code stops there and waits until our message comes.
Right.
The non-blocking one usually have this like inside of the loop.
Mm.
And the non-blocking one will just keep spinning, and then when it passes it, if there's nothing there, it will continue. The blocking one will just stop.
Gotcha. Was everyone able to hear that? Okay, so the blocking connection will stop program execution, hence the word blocking. And then once it connects, it will continue. If you do the other connection, which I'm going to guess is select connection, because that sounds right, you can put that in a loop, and you can just keep trying to connect. And you can have other logic in there too, like maybe you want to print something when it doesn't successfully connect or whatever. And in that way, you can have it be asynchronous if you want to do other stuff while trying to connect. Is that accurate?
I think so. But I'm guessing this is based on like Redis.
Yeah. So let's take a look real quick.
I think you should like provide an adapter or some kind of.
Yeah. So you should probably provide an event loop with select, though. Yeah. But in this case, we're not really worried about asynchronous stuff. We're just going to go with the blocking connection, and it'll be okay. So after that, let's go ahead and create a channel. As for the purpose the channel serves, this is only intro level. We're not going to go too deep into stuff, okay? So just know that once you create a connection, you create a channel, and then within a channel is where you do all the work. It's kind of similar to a database cursor. So now, everything's cool. Let's actually make an exchange. So what we can do is on our channel, we can say exchange declare. Now this is getting back to what you were saying earlier about defining stuff in advance. We can just do it here. The client basically says, there should be an exchange like this. And the server says, okay, I'll make it, or okay, there already is one. And it's all good. And then we say, what is the name of the exchange? In this case, we're just going to call it languages. And the exchange, and that's just an arbitrary name. You can call it whatever you want. And then the exchange type. We're going to do a topic exchange, like I mentioned earlier. That's just the example we're going to do today. Okay? So far, so good? All right. And now, we're going to do a little bit more like fancy programming stuff. We want to say that while true, let's go ahead and send a message. Okay? And then let's sleep for just 1 second, because we want to like keep stuff going. Now, while true, infinite loop, we want a way to exit. Send a message doesn't exist yet, and sleep we haven't imported. But get this typed, and then we'll fix all that. Okay, I just want to cover the ideas first. Okay? And then once you've got that, let's go ahead and import sleep. So if you're on Visual Studio Code, you can just put your cursor over it, control period, and you can just say from time import sleep, because we're not doing crazy async stuff. Blocking is fine. Okay? And then we're going to define our send message method. Okay? Let's also get rid of this. We don't need this right now. Okay? All right, so is everyone at this point so far? All right. So I want to get yeah, we're okay on. Do you guys want to do it the fancy-ish way, or do you just want to get it running?
Others mutually exclusive.
Yes.
You can do the get it running first and then decide.
Yeah. Okay. So let's do this where we can send a message, and we can say in our send message method, we can just do something like channel dot. Oh wait, hold up. We need to make sure the message function has the channel. Okay. So let's send the channel there. I don't like global variables. Call me old school, I guess. And then we can say just do a basic publish to that channel, and we're gonna publish to our languages exchange. Okay. And then we're gonna set the routing key. Let's just leave it. Let's just leave it empty for now. And then for the body, let's just say hello. Okay. And then just to help our debugging, we can say sent message. Okay.
Question is the routing key required? So you can just leave it out if you don't do
Yeah, you can leave it out because you can wait. There is a case where leaving a blank routing key is a problem. I don't forget what case that is. So let's test it out.
I mean, in the library, like an optional parameter where you can just
Ah.
like defaults to blank.
So I've noticed that the docs for this are not great. Like it doesn't. So when you do this exchange, or let's look at this channel object. I already forgot what I was looking for. Oh, routing key under basic publish. Here we go. Routing key, yeah. Yeah, it is required. But as I recall, there was somewhere in the documentation where it said the routing key is a required parameter, and if you enter blank, it'll still complain. A linter is not going to catch that. I don't remember if that was for topic exchanges, though. So let's test it and find out. All right, so all good here? Cool. So at this point, we have something that should run, hopefully, maybe. Let's try it out, because this doesn't match my example, but we're going to go for it. So now, everyone's got this written out, right? Cool. I think we may not have enough time to do, let's see how it goes. So now let's do Docker compose up, but this code is getting built into a Docker image. So we want to tell Docker, hey, build a new version of the image, okay? Otherwise, it's not going to get this updated code. So don't forget this -- build flag, okay? So let's do this. All right, so RabbitMQ is up, and it's seeing that it sent a message. Okay. So now, if we go back to our browser here, and we go to, really, why did I close it? That's right, because I thought we didn't need it anymore, and I was wrong. Okay, so if we go back here, we look at our exchanges, we can see our languages exchange. Okay. And we can see that we're getting about 1 message per second, which makes sense. We had it in a loop where we were sending a message and then sleeping for 1 second. So 1 message a second seems perfect. And we don't have any way to fetch the message because we don't have any queues yet. But we could. You don't have to follow along with this part. I'll just demonstrate. We could make a test queue. We could then bind the queue to our languages exchange. And then we could get a message, and we can see this hello. And we can see that the number of messages on the queue should be growing. Yep, here we go. Because we're adding a new message every second, and it's pulling every 5 seconds. So we're going to see it go up in about increments of 5. So yeah, Does that all make sense? So far, so good? Cool. So let's do it the quick and dirty way first for producing and consuming. And then we can make it more fancy, if we have time. Sound good? All right. So now, let's go ahead and kill this, because we don't want RabbitMQ to take all the messages. And let's go ahead and let's collapse our producer for now. And let's go to the consumer. I'm just going to open a new terminal, just because I don't want to get confused between stuff. And I'm going to go into the consumer directory. Okay. And just like before, let's make a new Python virtual environment. Granted, in hindsight, maybe we really didn't need to, but it's fine. And then let's activate that environment. And then let's do our pip install -e dot. Okay, same as before. Everyone's good with this? Give folks a minute to catch up. Should have got the chair. All good? Good, good, good? Okay. All right, so now let's open up our main again. There we go. And just like before, let's import Pika. Get my example here. Here's my example. Oh, right. Sorry, give me a second here. I got to pull up my example. Okay, there we go. Just like before, because I'm paranoid, I'm going to do, print starting. And starting. And we're going to connection equal, we're going to do the same thing. Okay, same as before. And again, same as before. Okay. And then, oh, we actually did not need to do that. Cool. I will remove that from the code later. All right, so everyone's got to this point, right? You've seen all this before. This is nothing new. Okay. And now, let's go ahead and declare some queues. So in this case, again, we're doing this kind of like calligraphy gift card kind of thing. So let's set up a billing queue. Okay. So let's do a queue declaration. Oh my god, I cannot type blind apparently anymore. And let's do a queue declare. And let's set the name to billing. Okay? And let's go ahead and set durable to true. Just to kind of demonstrate, because durable, there are that is probably one of the more likely options you will be to use. Not in every case, but it's something you should be aware of. And again, durable is persisting to disk. Okay, so that creates the queue. And then let's go ahead and bind the queue. So let's say channel queue bind. And we're going to bind it to our languages exchange, right? Because that's what we called it in our producer. And the queue gets set to the queue name. Now here's the thing. We declared the queue as named billing, right? But RabbitMQ may add some other stuff to it. So the safe way is to grab the queue declaration and on the method, get the queue name. This is just kind of the common way to do it. You can just memorize this part, okay? And then you set the routing key. Sorry? We just did blank. But yeah. We can do that. That works. Yeah, okay. So let's just do star.star for now. Okay, and I'll explain why in a little bit. So now if we do the star dot star, we have to, that's right, that's how I did it. We have to, on our producer, make sure it matches, right? So let's go over to our producer again. And instead of doing a blank routing key, let's do something. Remember, we were doing this kind of calligraphy gift card thing. We said there could be physical or digital gift cards, and there could be, you know, Korean or English. So let's do like physical dot English, because I wrote hello in English, okay? So we can do this as our routing key, all right? Everyone's good on that change in the producer file? Cool. And then back in the consumer, we do star dot star, and that will match any routing key that has 2 parts, okay? So this will match everything. Now when we get to the more final example, you'll see why I did this. And then we want to set up consumption. So that binds the queue, but then we want to actually consume from that queue in this program right here. So we can do channel.basicConsume, and we can say that the queue is equal to this guy again, or we could put this in a variable. It's up to you. In the example code, I put it in a variable. And then when we consume a message off of this queue, we need to run some kind of function. Okay? So we call this an onMessage callback, and that's a callback function. And I'm going to call that function billing processor. Okay? Now that function doesn't exist yet, okay, but that's what we're going to call it. So far, so good? So.
So it looks a little bit repetitive that you're binding to the queue and you're specifying the queue there, and then in basic consum you specify the queue again. Is that because you can bind to multiple queues?
Yeah.
In here with the channel, and
Yep.
you can consume from the one that you want?
Yep. So you can declare any queues that you want here. You can bind any queues, and then you can consume from any queues. So you have to specify which one, because you could do all sorts of different stuff in different steps. You could actually have a chain of exchanges in queues as well. So you can also have like multi-subscribe and all sorts of crazy stuff. So yeah, that's why there's a bit of repetition, because there are options. Other questions? All right. So now that we have our basic consume, the last step is to tell it, start consuming. And now this is a blocking call. It will continue trying to consume until the program terminates. Okay. Now you're probably getting a warning about this. We haven't defined it yet. We'll get to that in a second. All right, so everyone's got this part down so far? Great. So now let's define that billing processor method. Oh my god. Reminds me of StarCraft. Oh my god, he's whack. What am I doing? Okay, no, wait, no. Oh, jeez. Okay, here we go. And then that takes in a channel, a method, and properties. I believe. I'm not 100% sure. I don't remember. And I did a bad thing. I think it's properties. I'm not actually sure. But in this case, I'm not going to use this, so I just do underscore to let VS Code and other engineers know that I'm not using that parameter. And then we can say, we can get our routing key. So we can say, if it's a physical gift card or a digital gift card, we could do, media format as method.routing key, and we can split it on a dot because the routing key is split by dot, and then we can get the first one. Because remember, if we look at this one here, we have the media here, whether it's physical or digital, and then we have the language as the second one, English or Korean. And maybe we want to get the media format, and we can say, if the media format is digital, we can say, charging 100 Korean won for a digital card, or we can say physical. We can say, you know, charging 1,000 Korean won for a physical card. And then we could say, like, otherwise, you know, do some not implemented error or something. Something like that. Yeah? What's up?
Check if that second parameter is supposed to be method or message.
Recommended method.
Okay. This method is
Yeah.
like a new concept.
So in reality, these parameters are properties, I think, and body.
Because they're positional args, you can call them whatever you want, it will still work.
Right.
But just what's the method? Like I understand what like a message would be,
Mm.
and I want the relativity of the message that you're consuming. But like, what's a method?
As I understand, is kind of the method of transit, right? So what was the method according to which it was routed? What was the method according to which it was, you know, fanned out or directed or whatever, this kind of stuff. The method of exchange. Does that make sense? Cool. That's a total guess, by the way. You should check it. And because the Python docs are not great, so I can't really find out without diving deep. What's up?
But for this case, right, instead of split, you should use header for this one, right?
Sorry?
When you're sending multiple messages, instead of like splitting the key, maybe the header might be a better idea.
What do you mean by the header?
Like when you're sending a message, you can add a header saying this is English or this is digital or physical.
Ah,
That's the header, you can process that.
that's a good point. That is a very good point. I'm not sure exactly how RabbitMQ's API allows you to do that, so I'm not going to do it right now just because of time, but that is a very good point. So it was mentioned that, you know, kind of splitting the key is maybe not the best way to do this. It might be better to inject some information into the message header and base it off of that. Very, very good point. I have not taken the time to figure out how to do that, but I'll update the example GitHub repository to use that method if I can figure out how in a short time, and we'll do it that way, because that does sound much better. Cool, so any other comments before we continue, or questions? All right, so now what we can do is, last thing we can do is we can say print generating card for message, and let's make this a format string. And we can say body.encode, you know, UTF-8. Because this is actually bytes. Let's also get rid of this. Okay. Does that all make sense so far? So now when we receive the message body, the message passed along the queue, it is in bytes. So we have to encode it to text. We're going to encode it to UTF-8. Okay? All good? So now we can docker compose up and build and really hope this is going to work and hope I don't have any stupid little errors. But we're going to find out. Whee! Damn it. Oh, decode. Yeah, I totally live in a country that doesn't have a standard ASCII. Yeah, I should have looked at my example. It is decode. Sorry about that, guys. I got them backwards. Because you're decoding the bytes into text. Right. I guess you could argue the other way around, too. I don't know. Oh, come on, dude. Come on. Come on. We're over time. I want to go fast. Maybe I should have reorganized the Docker file. Actually, no, those are all cached. Oh, that's right, because of... I should have done it differently. Oh well, whatever. I should have just mounted the project. It's fine. Okay. So... all the clustery stuff. Yep, all the welcome messages, status warnings, and it's going to be up right about... oh, come on, man. Now, okay. And then within 5 seconds, we should see... or not. Come on, guys, really? There we go. There we go. Okay. So you see the producer sends a message, the consumer pulls it off the queue, checks the routing key, which is not the best way to do it, likely. And then, you know, based on the routing key, does some logic, and then prints what the message was. So yeah. Does that make sense to everyone? Does everyone understand how this works? Cool. All right then. So, a couple more things before we end. So I have a more complete version of this, where, but we're too tight on time. So this one does like a little bit more logic around, you know, the English and Korean thing or the media. So it kind of randomly selects the language and the format and does the routing based on that. We also do some kind of signal handling to make sure we handle interrupt signals properly and to make sure that we break out of our loop and all that kind of stuff properly. And then on the consumer side, we actually have 3 consumers. We have our billing processor that we did just now, and I also set one up for kind of English and Korean to kind of, you know, demonstrate how the routing works and how messages get routed to one processor and not another based on the topic's routing key. So this is all on the GitHub. If you go to the repository here, you'll see this MQ config, consumer, and producer branches, and that's where you can see the various stages of the completed code. Okay? So definitely check this out later to kind of get an idea of a more complete example. Again, not 100% complete, because it's definitely not like a real-world use case, but I hope this gives some kind of idea. So now, let's kind of wrap things up. So, we also wanted to talk about example cases. So we talked about the theoretical use cases or the theoretical situations where you would want to use a message queue. But what about like real world industry and product applications, right? So chat applications are a very, very, very obvious and clear example of when you would want to use a message queue. You have a very high throughput rate. You have lots of different kinds of consumers. You need to be able to route messages very cleanly and clearly. Message queues are absolutely critical in chat applications so that things function properly. If you're doing real-time sports analysis, because the person who asked for this, or who had the initial idea for this event, was actually trying to solve this problem with message queues. That's a very good use case for message queues, right? As stats are coming in, you want to consume that information, update your data set, and trigger kind of updating your whole aggregate statistics. Excellent use case for message queues. Weather tracking and forecasting, same idea. As you're getting stuff in from Doppler radar, as you're getting stuff in from various kind of humidity sensors or temperature sensors or whatever, you want to push that data in and get it processed on the fly. Again, we've mentioned it like 3 or 4 times now, financial systems. Again, absolutely critical use case for message queues. Or shipping and logistics systems, right? As, you know, your coupon delivery guy drops the package and sends the photo, that pushes into the queue, which then goes through the database to update the order, goes to the notification service to send you a message, all this kind of stuff. Distributed ordering systems, like our example, where we have kind of, you know, an ordering system for these kind of calligraphy gift cards, and you want to distribute it to different kind of workers based on the logic, this kind of stuff. And just generally, any kind of event-driven system. Anytime you want to trigger something in response, and you want it to be a little bit decoupled and you don't want a direct API call, message brokers are the way to go. So does this all make sense? Cool. Any questions?
There's some kind of overlap for data pipeline systems like Airflow, where you could use this for your data pipeline. And I don't know if you have experience with that.
So for the benefit of the stream, Gordon mentioned it seems like there could be a bit of overlap with data pipelines, for example. I do a lot of data pipelines, and I actually don't do a lot of message broker stuff, if you couldn't tell from this presentation. Yeah, so for my data pipelines, I use Prefect, which is very similar to Airflow. But the difference is, whereas RabbitMQ doesn't really do anything with the messages except routing, right? It doesn't really do a whole lot of transformation, a whole lot of analysis, any aggregation, any enrichment of the messages coming through. It's just like message in, message goes that way, out, right? And it's meant to be like super fast. Data pipelines, you can do event-driven systems also with data pipelines, but data pipelines are more focused on doing stuff with the data. They do something to the message that gets sent. They maybe do some kind of aggregation, or they do some calculation, or they fetch data from some other source to enrich the data even further. That's not a good use case for message queues. I haven't done any kind of benchmarking or research, but I would imagine that message queues are way faster than data pipeline systems, because data pipeline systems can do a whole bunch of logic. They have a whole bunch of hooks, many systems for task organization and this kind of stuff, whereas data pipelines are just like message in, message out, just get out as fast as you can, right? So I imagine that there's a big performance difference, but I don't have any real evidence to support that, just kind of logic.
So the data pipelines have like much more for the whole logic of designing the pipeline.
Yeah.
Whereas this is much simpler and faster.
Simpler is arguable, but faster theoretically, yes. So yeah, data pipelines, you can have all sorts of crazy logic that can be much more complex, whereas message queues, you can have like a crazy kind of series of message queues all feeding into each other based on different logic, and you can actually have kind of callback loops of message queues based on certain things, which can get quite complex. But the message queue itself is just data in, data out. Cool. So any other questions? Cool. So with that, I should have gone to the questions thing. Or yeah, any final questions about anything we went over today? So
we've used RabbitMQ in the past in like a serverless Lambda kind of situation, and one problem we ran into was that the connections were expensive. So it seems like RabbitMQ wasn't really designed with these kind of short running processes in mind, but
yeah.
it was intended to be used with like long running stuff.
Mm.
And I just wonder if you have any experience with that, or do you have any workarounds for that?
You could do like a connection proxy kind of thing, maybe similar to how. So for the benefit of the stream, Gordon was saying that in past experience he set up a service kind of like AWS Lambda, where he had services kind of spinning up new RabbitMQ connections, handling operations, and then kind of closing connections. And RabbitMQ kind of didn't like that thrashing of connections, that quick connection up, quick connection down kind of thing. And he was asking if if I had any experience. I don't have any direct experience, but I would guess that there's a SQL proxy, which is used for databases very often, which kind of serves a similar purpose, where it handles all the connection stuff and then just otherwise delegates the traffic. I imagine you could do a similar thing with RabbitMQ, where you could have some kind of connection proxy that maintains the active connection to RabbitMQ, and then the clients can just connect to the proxy, and the proxy can handle the weight of connection up, connection down. Would be my guess. Haven't tested it. Yeah. Any other questions or ideas? I think you had one too? Yeah.
Just another question. How should we test RabbitMQ for message broker like Kafka?
So the question was, how should we test message broker like RabbitMQ and Kafka? It depends on what you're testing it for, right? So you might be testing it for throughput. You might be testing it for features. Obviously a feature test would come first, because if it doesn't do what you need it to do, like, you can't use it, right? And then it also depends on beyond feature testing, the big test would probably just be performance. And then it depends on your use case. So for Gordon's example, you might want to test, like, can it handle thrashing connections, right? Or you might want to test with, if you have a high variance in message sizes, you might want to set up some test producers to produce large messages and small messages and see how it handles it. Or if you have very complex pipelines, right? And then you just kind of want to set up equivalent configurations in both systems and then just do a benchmark test. At least that's how I would do it. Does that answer your question? Cool. What's up, Tom?
Which message broker is a good default option if you don't know what you're doing?
So which message broker is a good default option if you don't know what you're doing? So I've messed with Kafka a little bit. I've messed with RabbitMQ a little bit. I've messed with Redis PubSub a little bit. Redis PubSub seems very, very simple, which is great for getting up and running quickly, but I didn't really figure out how to do any more advanced stuff with it, but in that specific use case, I didn't need any more advanced stuff. RabbitMQ seems like a nice balance between complexity and capability. Like, I only spent this week preparing the presentation. In total, maybe like 6 hours, which is not bad for all the stuff that we covered, right? And it was pretty easy to pick up. Kafka's complicated. It can do a whole bunch of crazy stuff. It handles high throughput very, very well. It is very memory hungry because it's Java, or at least I believe it's Java as I recall. Okay, but it handles throughput very, very well. So, you know, kind of do benchmarks, check your complexity, and kind of whatever you can figure out the fastest and gets the job done. Yeah, personally, I kind of like RabbitMQ. The documentation makes sense to me. The tutorials are quite good. The concepts are pretty simple and clear to understand, but still allow you to get a lot of stuff done. Prefect is not a message queue. Yeah, you could use it as one, but that I would not recommend it. If you need to do like data pipelining where you need to modify data or do more complex time-consuming operations, then I would use a data pipeline system like Prefect or like Apache Airflow or anything like that. But for just like message in, message out, use an actual message queue, I would say.
I think the cloud providers have some built-in like SNS or
SQS.
event broker,
Yep.
SQS.
Yeah, so that's a good point. And for the benefit of the stream, Gordon mentioned that the cloud providers also have message broker implementations. So Google has Google PubSub, which is, surprise, a publish-subscribe model of message queue. AWS has SQS, the simple queuing service. It also has SNS, simple notification service. The difference between them is a little bit subtle. SQS is more like a proper queuing system, whereas SNS is meant more for just like very simple, very, very simple notification systems, usually used with like text messages or Slack messages or something like that. Event Broker, I guess, is Azure's, I think.
Yeah, AWS also has like a separate event broker thing. I don't know why, because we just used SNS
Okay.
as an event broker for ourselves. So,
Fair enough. Okay, cool. But yeah, does that kind of answer your question then? Cool. Any other questions? All right, so I know that there was some stuff that we wanted to go over at the end. We said there were 2 things, and I've already forgotten what they are. But we're over time. So I'm going to recommend that if there's more stuff that you want to look up or questions that you want to get answered, we have a Discord. So to recap what we covered today, we covered what is a message broker. We covered why should we use a message broker and when should we use them, what types of message brokers there are. And then we went a little deeper into what is RabbitMQ. We talked about the AMPQ protocol with like exchanges, queues, messages, acknowledgements, all this kind of stuff. And then we went over some code ourselves and some example use cases. If you want more information, you can check these additional resources. There's this blog post that is kind of at the introductory level. It's very similar to what we presented today. And then there's also the RabbitMQ tutorials, which are quite good. They're very small and contained, but they get the concepts across pretty clearly. And then there's the big AMQP documentation, which we went over together in the browser. Additionally, the video this was live streamed on YouTube. And so it is recorded on YouTube. If you want to go check it out, the link is here in the presentation. I will also share the presentation in Discord. And the GitHub repo is also here. And lastly, thank you for coming. If you're not on our Discord, I recommend joining. You can ask questions. We can continue discussion of RabbitMQ things or message broker things in general. I'll leave this up on the screen a second for people to scan the QR code. And we are a registered nonprofit here in Korea. If you are watching online, we do not currently have a way to accept donations, but if you were thinking that, we appreciate the idea. If you do want to donate, there's our info. The donation, using this space is free. Lunit does sponsor us for purposes of these events, so that's not the thing. But we're all, well, I'm not because I'm sick and I don't want to get you guys sick. But you all, if you want to, I'm going to give the company card to Daga, and you all can go get some chicken, and Code Soul will pay for it with some donations from the organizers and whatever donations you guys give, so kind of pooling money. So wait, but Beege, if we're just donating money to Code Soul, then why is Code Soul paying? Why don't we just split the check? Because we are trying to get to the next level of nonprofit, because apparently there's like a level system for this. And in order to do that, we have to show money going into and out of the account. So if you send money to us and then we pay for things with that money, we show that we're actually doing business as a nonprofit. And then we're going to start, we were supposed to start it this week. I have to follow up with Kyle. Once we get to that next level of nonprofit, we can accept corporate donations, which is the real money. And then we can actually pay people to teach stuff, which means we can get more and better people to teach stuff, because I don't know what I'm doing half the time. And we can also like rent out other larger venues. We can hold bigger events. Basically, we can do more with the money we get from that. So even if you only donate like chon won or something, like 1,000 won, that still helps because it matters like how many different people are donating and then that we're getting money to pay for stuff. So sorry that was so long, but again, thank you for your time. Join the Discord, ask questions. We can all learn from each other. And thanks again.